Tonight, we uncover the terrifying reality that the universe's most violent deaths are traveling toward us in total silence, hidden by the very light that will eventually announce our destruction. Imagine stepping outside on a crisp, clear evening. You look up at the familiar constellations, Orion, the Great Bear, the faint glimmer of the Pleiades, and you feel a sense of profound, ancient peace. These stars have guided mariners for millennia. They are the ultimate constants in an ever-changing world. But this sense of security is the greatest deception the cosmos has ever played on us. Because of the finite speed of light, you aren't looking at the universe as it is right now. You are looking at a series of ghosts. Somewhere out there, in the dark voids between the points of light we recognize, a star has already died. It has already collapsed, rebounded, and unleashed a torrent of radiation more powerful than 1 trillion hydrogen bombs. That weapon is currently screaming through the vacuum of space at 186,000 miles per second. It is invisible, it is silent, and it is already closer than you think. By the time our telescopes register the first flicker of its arrival, the window for preparation hasn't just closed, it has been incinerated. We call this the too late paradox, the moment the warning and the weapon arrive as one. The illusion of cosmic silence is the foundational lie of our existence. We have spent the entirety of human history operating under the assumption that distance is synonymous with safety. If something is 50 light-years away, we believe we have a 50-year buffer zone, a celestial DMZ that grants us time to observe, to react, and to survive. But this is a fundamental misunderstanding of cosmic latency. The universe is not quiet, it is merely delayed. Every star you see is a message sent from the past, and some of those messages are carrying a death sentence that has already been signed. When we look at a star like Betelgeuse or the white dwarf Pegasi b, we see them as they were centuries or decades ago. We discuss their eventual deaths in the future tense, as if we are spectators watching a countdown clock that hasn't started yet. But in the grand, indifferent theatre of the cosmos, that clock may have hit zero while our ancestors were still fighting the Industrial Revolution. The energy of that explosion is currently bridging the gap, eating through the light years with relentless precision. The danger isn't just the explosion itself, it is the fact that we are living in a cosmic shooting gallery where the bullets travel at the same speed as the image of the shooter. This creates a terrifying reality that modern astronomy often glazes over. Most documentaries will tell you that a supernova within 50 to 150 light-years would be a spectacular sight, a guest star so bright it would cast shadows at night and be visible in broad daylight. They paint a picture of scientists at neutrino observatories receiving a signal hours in advance, giving humanity a brief but critical moment to brace for impact. But they are operating on the safe distance model. What they ignore is the dark supernova or the dust-masked explosion. Space is not a perfect vacuum. It is filled with vast, undulating clouds of interstellar dust. These clouds act as a cosmic shroud. If a nearby star detonates behind one of these veils, the visible light, the very signal we rely on to see the event, is scattered and absorbed. However, high-energy radiation, the X-rays and gamma rays that strip atmospheres and mutate DNA, can penetrate these dust clouds far more efficiently. In this scenario, Earth isn't greeted by a brilliant new light in the sky. Instead, we are struck by an invisible hammer while the sky remains perfectly, mockingly dark. We wouldn't even know we were under attack until our global infrastructure began to melt down and the very chemistry of our air began to turn toxic. This brings us to the core of the too late paradox. We are biologically and technologically wired to respond to visual stimuli. If we can't see the threat, we don't believe it exists. We map the danger zone within 50 light-years and congratulate ourselves on the fact that no obvious candidates are currently on the verge of collapse. But our maps are incomplete. We are existing inside a cosmic void, a low-density bubble of space likely carved out by tens of supernovae that exploded in our neighborhood millions of years ago. We are the survivors of a historical bombardment we don't fully remember, and we assume the current quiet is the norm rather than a temporary lull. Consider the psychological impact of this cosmic latency. Humanity has a deep, ancestral need for the sky to be a stable backdrop. We find comfort in the fact that the North Star stays put and the constellations wheel overhead with predictable rhythm. A nearby supernova shatters this illusion of permanence. It reminds us that we are not living in a sanctuary, but on a small, fragile rock, moving through a dynamic and often violent environment. The too late paradox suggests that for a technological civilization, the first moment of awareness is also the moment of peak vulnerability. Imagine the scientists who monitor the sky. They are looking for the Kepler event, the bright flash that Johannes Kepler saw in 1604, which stayed visible for over a year. But the Kepler supernova was 20,000 light-years away. At that distance, the inverse square law of radiation protects us. The light is a curiosity, not a killer. But if you move that same event into our immediate neighborhood, the physics changes from a light show to a planetary lobotomy. The energy doesn't arrive as a polite notification, it arrives as a massive, sustained assault on the Earth's protective systems. The most disturbing implication of this silence is the interpretation challenge. We assume that if a nearby star exploded, our sophisticated instruments would immediately tell us what was happening. But would they? In the early stages of a masked or dark supernova, the signals would be messy. A sudden spike in the neutrino flux might be dismissed as a sensor glitch or an unprecedented solar flare. An atmospheric anomaly might be blamed on human-caused climate change or a localized weather event. Because we have never experienced a nearby supernova in the age of instrumentation, we have no baseline for what the end of the world actually looks like on a computer screen. We are essentially a species that has lived its entire life in a room with a 50-year delay on the windows. We look out and see a beautiful, calm garden. But the garden could have been on fire for the last 49 years, and we wouldn't know it until the glass itself started to melt. This is the illusion of cosmic silence. It creates a false sense of security that prevents us from preparing for the inevitable. We treat the death of stars as a distant academic interest, failing to realize that the stardust in our veins is a reminder that we are products of the very violence that now threatens to erase us. As we stand under the night sky tonight, we must confront the uncomfortable truth. The silence of the stars is not a sign of peace. It is a sign of distance, and distance is a dwindling resource. The universe is not waiting for us to be ready. It is simply moving at its own speed, carrying a billion-year-old message of destruction that might be just seconds away from being delivered. We are living in the lag time between the trigger being pulled and the bullet hitting the target. And in the grand scale of the cosmos, that lag is the only thing we have ever known as history. The true mystery we have to solve isn't whether a star will explode near Earth. We know that, statistically, it eventually will. The mystery is whether we have already missed the warning. Have the first particles of the dark supernova already entered our upper atmosphere? Has the silent sabotage of our electromagnetic shield already begun? We have spent centuries looking for a sign in the heavens, but we may have been looking for the wrong thing entirely. We were looking for a light in the dark, but the real threat is the darkness that arrives before the light. This is the state of our world, a planet in a cosmic shooting gallery, blissfully unaware that the silence of the night is actually the roar of an approaching cataclysm, muffled only by the vastness of space. We are waiting for a spectacle, but what is coming is a reckoning, and by the time we finally see it, the only thing left to do will be to watch the sky change color and wonder how we could have been so blind to the silence. The first indication that our history had ended didn't come from a telescope or a panicked satellite feed, but from a profound and terrifying silence in the deep places of the Earth. Thousands of feet underground, shielded from the noisy radiation of the surface by miles of solid rock, sit the world's neutrino observatories, vast subterranean cathedrals filled with ultra-pure water and lined with thousands of golden light-detecting eyes. These labs were built to catch ghosts, particles so elusive that they can pass through a light year of solid lead without ever brushing against an atom. For decades, the scientists working the graveyard shifts in these labs have operated under a condition of hyper-vigilant boredom, monitoring a steady, predictable trickle of particles from our sun or the faint, dying whispers of stars in distant galaxies. They were trained to expect a safe distance signal, a brief, manageable spike that would give humanity hours to prepare before the visible light of a supernova finally reached our atmosphere. But the too late paradox begins with a signal so massive that it doesn't look like a discovery. It looks like a total system failure. At precisely the moment of the collapse, far out in the local neighborhood of our galaxy, a massive star, perhaps one we had never properly catalogued, or one hidden behind a mask of interstellar dust, reached its inevitable breaking point. For millions of years, this star had been locked in a delicate, high-stakes battle between the crushing inward pull of gravity and the explosive outward pressure of nuclear fusion. But in the final seconds of its life, the fuel ran out, the fusion stopped, and gravity finally won. The star's core, once the size of the Earth, collapsed into a sphere just 30 kilometers across in a fraction of a second, accelerating inward at 25% the speed of light. This was the moment the weapon was forged. In that instant of supreme compression, as protons and electrons were crushed together into neutrons, an unbelievable flood of energy was unleashed, not as light, but as 10 to the power of 58 neutrinos. This ghostly flood represents the vast majority of the supernova's energy, and because neutrinos interact so weakly with matter, they are able to scream out of the collapsing core hours before the physical shockwave even reaches the star's surface. They are the universe's only true early warning system. But because the explosion occurred so close to Earth, well within the 50 light-year danger zone, the sheer density of this particle flux was unlike anything our models had ever predicted. When this tidal wave of neutrinos struck our subterranean detectors, the data didn't just spike, it flatlined. The sophisticated electronics designed to count individual particles were suddenly being hit by a flux so dense it was as if they were trying to count the individual drops of water in a breaking dam. Inside the control rooms of observatories from the ice of Antarctica to the mountains of Japan, the reaction was not one of triumph, but of profound confusion and skepticism. The interpretation challenge is the first failure point in our survival. The scientists on duty didn't see a supernova, they saw what appeared to be a catastrophic sensor error. The numbers on their screens were physically impossible, according to the safe distance models we had relied on since the detection of supernova 1987A. In 1987, the neutrinos arrived as a polite, discernible increase that allowed for careful verification. But this signal was a roar that seemed to suggest the detector itself had been struck by a massive electrical surge or a localized radiation leak. The debate began immediately, eating away at the precious few hours we had left. Lead researchers were woken by frantic calls, not to announce the death of a star, but to troubleshoot a perceived glitch in the hardware. They argued it had to be the electronics pointing to the impossible flux density. They suspected a solar anomaly, perhaps an unprecedented solar flare that had somehow bypassed our magnetic shielding, or a software loop that was feeding back on itself. They were looking for a signal that matched their expectations of a distant, academic curiosity, and when the reality of a nearby cataclysm arrived, it was dismissed because it was too large to be real. This is the psychological trap of the too late paradox. We are so conditioned to believe in our own safety that we will rationalize away the evidence of our destruction until it is too late to act. While the scientists debated the integrity of their sensors, the physical reality of the collapse was continuing its relentless march toward our world. The neutrinos had already passed through us, invisible and mostly harmless, but they were merely the scouts for a much slower and much more lethal army of radiation. The visible light and the high-energy X-rays and gamma rays were still on their way, traveling at the absolute speed limit of the universe, hidden in the wake of the neutrino flood. Had the scientists recognized the signal for what it was, the announcement of a nearby stellar death, humanity might have had a window to ground aviation, shield critical infrastructure, and prepare for the atmospheric assault. But that window remained open only as long as the neutrinos preceded the light. Instead, the glitch theory gained momentum. Because no visible change had yet occurred in the night sky, there was no visual confirmation to support the subterranean data. The star, hidden perhaps by a shroud of interstellar dust, or simply lost among the billions of other points of light, had not yet announced its death to our telescopes. To the astronomers on the surface, the sky was as quiet and eternal as it had been for 10,000 years. They saw the neutrino alert as an interesting but likely flawed data point, a curiosity to be discussed in the morning. This is the core of the too late paradox. The distance that should have been our buffer was actually the mask that hid the threat. The irony of this missed warning is that we had spent billions of dollars building the very instruments that could have saved us, only to let our own cognitive biases render them useless. We assumed that the end of the world would look like a clear, recognizable signal that followed the rules of our textbooks. We didn't account for the fact that a truly nearby supernova would break our instruments long before it broke our world. By the time the researchers began to realize that the signal was consistent across multiple independent observatories, that it wasn't just a glitch in Japan but also in the Antarctic and the deep mines of Canada, the time for preparation had already vanished. As the debate in the labs finally shifted from asking if this was a bug to realizing it was real, the atmosphere itself began to provide the answer. The electromagnetic cascade, the first silent sabotage of our infrastructure, was beginning to ripple through the upper ionosphere. Satellites began to report mysterious bit flips in their memory banks, and the GPS network started to drift. The neutrino flux, though it had peaked and begun to fade, had left behind a legacy of confusion and wasted time. We had been given the ultimate cosmic heads-up, a flood of 10 to the power of 58 particles, and we spent it arguing about whether our machines were broken. The failure of the neutrino early warning is the final evidence of our cosmic vulnerability. It proves that even with the most advanced technology humanity has ever conceived, we are still fundamentally limited by our inability to process the sheer scale of the universe's violence. We are like ants, trying to understand the arrival of a tidal wave by looking at a single drop of water on a sensor. The neutrinos were the first chapter of the too late paradox, the silent ghost that tried to scream a warning we weren't ready to hear. And as the scientists finally began to reach for the emergency broadcast phones, the sky above them was already beginning to turn a color that no human being was ever meant to see. While the scientists in their subterranean vaults were still debating the integrity of their sensors, the first physical blow from the dying star was already landing, not on the ground, but against the invisible electrical veil that wraps our planet. We have always viewed the ionosphere as a silent protector, a layer of charged particles that bounces our radio waves and shields us from the sun's more erratic moods. But under the assault of a nearby supernova, this shield is transformed into a conductor for our own destruction. This is the beginning of the electromagnetic cascade, a phase of the too late paradox, where the infrastructure of the 21st century begins to dismantle itself while the sky remains mockingly, perfectly blue. The transition from a data glitch to a global emergency starts in low Earth orbit. Imagine a satellite, a multi-billion-dollar masterpiece of engineering, quietly stationed keeping 300 miles above the Pacific. It has no way of knowing that a wall of high-energy X-rays and gamma rays traveling at the absolute limit of light speed is about to wash over it. Because these rays are invisible to the human eye and often masked by the very interstellar dust that hides the supernova's visible flash, the satellite is the canary in the coal mine. But it doesn't sing, it simply malfunctions. The radiation doesn't melt the metal or shatter the glass. Instead, it performs a kind of digital lobotomy. High-energy photons scream through the satellite's shielding and strike the silicon wafers of its onboard computers. In the world of microelectronics, this causes what engineers call bit flips. A single zero in a string of binary code is forced into a one. On a normal day, cosmic rays do this occasionally, and error correction software fixes it. But now the bit flips are happening by the millions every second. Navigation systems lose their sense of direction, communication arrays begin to broadcast gibberish, star trackers designed to help the satellite orient itself by the very stars that are now killing it become blind with noise. One by one, the eyes of humanity begin to blink out. This is the silent sabotage. On the surface, the general public is entirely unaware of the celestial bombardment. There is no thunder, no heat, and no light. But the world begins to feel wrong in subtle, frustrating ways. It starts with the GPS. To the average person, a GPS failure is a nuisance, a mapping app that can't find a route or a rideshare that never arrives. But for the global economy, GPS is the invisible heartbeat. It provides the nanosecond precise timing required for high-frequency stock trading, synchronized power grids, and automated logistics. As the satellites drift and fail, the heartbeat of modern civilization begins to stutter. The aviation industry is the first to realize that this isn't a localized problem. Across the globe, pilots suddenly find their precision landing systems fluctuating. Long-haul flights over the poles, where Earth's magnetic field is most vulnerable, report massive spikes in radiation and total radio blackouts. Air traffic controllers, seeing their screens fill with ghost signals and losing contact with hundreds of aircraft, have only one protocol for an anomaly of this scale: ground everything. Within an hour, the roar of the global aviation network is replaced by a heavy, expectant silence at every major airport. Thousands of planes are tethered to the Earth, their pilots looking up at a clear, sunny sky, wondering why the most sophisticated navigation network ever built has suddenly vanished. This is the interpretation challenge, moving from the lab to the cockpit and the boardroom. Because the sky looks normal, the human brain refuses to accept a cosmic explanation. Governments and military leaders, blinded by the loss of their surveillance satellites, immediately turn to the most terrestrial fear: a coordinated cyber attack or a high-altitude EMP. The too late paradox creates a psychological fog of war. While the planet is being bathed in the radiation of a stellar collapse, we are looking for human enemies in the dark. We are checking firewalls and searching for submarines, failing to realize that the hacker is a star 50 light-years away that ceased to exist decades ago. As the electromagnetic cascade intensifies, the upper atmosphere begins to glow with an energy it was never meant to hold. The X-rays and gamma rays are slamming into nitrogen and oxygen molecules, ripping electrons away and creating a state of intense ionization. This doesn't just disrupt satellites, it turns the atmosphere into a chaotic mirror. Short-wave radio, used by emergency services and the military, becomes a cacophony of static. The ionosphere, usually a reliable tool for long-range communication, is now a roiling sea of electrical noise. We are being blinded just as we need our eyes the most. The most disturbing part of this stage is the dark supernova effect. In many outlier videos, the supernova is depicted as an immediate, blinding flash. But the law vault suggests a more terrifying possibility, that the star is shrouded in a dense cloud of interstellar dust. This dust acts as a filter. It scatters the visible light, delaying the spectacle, but it is largely transparent to the high-energy radiation that is currently sabotaging our world. We are being struck by the weapon before we can see the shooter. It is a planetary-scale ambush. Down on the ground, the silent sabotage begins to reach the power grids. The intense ionization of the atmosphere can induce ground-level currents in long-distance transmission lines, similar to the effects of a massive solar storm, but sustained and global. Transformers begin to hum with a low, ominous frequency. In some regions, the grid simply trips, plunging entire cities into darkness. In others, the surge is too great and the infrastructure itself begins to burn. And still, if you were to walk out of your darkened house and look at the sky, you would see nothing out of the ordinary. The constellations of Orion and the Great Bear would still be in their places, cold and distant. The moon might be a silver sliver. The sky is a mask of tranquility over a world that is electrically hemorrhaging. By the second or third hour of the cascade, the realization begins to dawn on the scientific community. The data from the neutrino observatories, the glitch they dismissed, now matches the catastrophic failure of the satellite network. The signal we ignored becomes the realization we can't escape. They understand now that they aren't looking at a software bug or a solar flare. They are looking at the arrival of a supernova's wavefront. But because they wasted the neutrino window in debate, they have lost the chance to warn the public in an orderly fashion. The chaos is now self-sustaining. Without satellites, without reliable long-range communication, and with a failing power grid, the ability to coordinate a global response is gone. We are a technological species that has been stripped of its technology in a single afternoon. The too late paradox has effectively returned us to the 19th century, but with a 21st century population that is entirely dependent on the systems that are now failing. As the sun begins to set on this first day of the event, the psychological tension reaches a breaking point. Millions of people are without power, stuck in grounded planes, or unable to use the most basic digital tools. They are told there is an atmospheric anomaly, but they can see the stars beginning to come out. They look for a sign, for a reason for the collapse, but the sky remains a deep velvet black. They don't know that the nitrogen in the air above them is being chemically transformed into poison. They don't know that the ozone layer is already beginning to leak away under the radiation bombardment. They are waiting for the day the sky changes color, but for now they are trapped in the silent sabotage. They are living in the final hours of the world they knew, a world where distance meant safety and the stars were just lights in the dark. The electromagnetic cascade is the final warning, the physical touch of a dying star reaching out across the void to tell us that the illusion of cosmic silence is over. And as the first hint of an unnatural, eerie bluish glow begins to fringe the horizon, a color no human has ever seen in nature, the too late paradox is about to move into its most visible and violent phase. For hours, the world has been stumbling through a digital blackout, a silent sabotage that has left our cities dark and our planes grounded, yet the heavens remained a mocking, indifferent velvet. But the too late paradox is about to reach its terrifying visual crescendo. This is the moment when the delay finally expires and the finite speed of light can no longer hide the violence of the cosmos. In an instant, the night sky is not merely interrupted by a new point of light, it is punctured. This is the arrival of the wavefront, a wall of energy that has been traveling through the void for decades, carrying the message of a star's death and the tools for our destruction in the same silent package. The first thing you would notice isn't a flash but a distortion. Among the familiar ancient constellations, a single point begins to swell. It doesn't flicker like a normal star. It burns with a cold, piercing intensity that grows more brilliant by the second. Within minutes, this guest star has surpassed the brightness of Sirius, then Venus, and finally the full moon. But unlike the moon, which reflects a gentle, scattered sunlight, this light is sharp enough to cast hard, ink-black shadows across the landscape. It is a light so powerful it outshines entire galaxies, yet it is currently focused on our small blue horizon. This is the visual announcement of the supernova, but the light is the least of our worries. Traveling alongside those visible photons is a much more lethal vanguard, the first concentrated wave of gamma rays and X-rays. As this radiation hits the upper atmosphere, the sky undergoes a transformation that no human being was ever meant to see. Most outlier videos describe a brilliant white flash, but the reality is far more disturbing and chemical in nature. Our atmosphere is a delicate cocktail of nitrogen and oxygen, a shield that has spent billions of years protecting us from the sun's relatively mild outbursts. But the radiation from a nearby supernova doesn't politely bounce off this shield. It slams into it with the force of 1 trillion hydrogen bombs. The energy is so intense that it begins to rip the very molecules of our air apart. This is why the sky begins to change color. High in the ionosphere and the stratosphere, the gamma rays strike nitrogen molecules, severing the powerful triple bonds that hold them together. These liberated nitrogen atoms, now highly reactive and excited by the radiation, begin to hunt for partners. They collide with oxygen, creating a chaotic, glowing plasma of ionized gas. The result is an eerie, bluish-white or violet luminescence that begins to fringe the horizon and bleed into the zenith. It isn't the warm glow of a sunset or the dancing ribbons of a solar-fed aurora. It is a steady, haunting radiance, the visual signature of the atmosphere's chemical foundations being dismantled in real time. The sky has become a planetary-scale laboratory, and we are the subjects inside the flask. As the nitrogen and oxygen atoms are torn asunder and recombined, they create nitrogen oxides, the very same compounds that form the brown, toxic smog over industrial cities. At this altitude, however, they aren't just a pollutant, they are an assassin. These nitrogen oxides act as a catalyst that begins to eat the ozone layer. The ozone molecules, which normally absorb the sun's lethal ultraviolet radiation, are chemically converted into ordinary oxygen. In these first few hours, our primary shield isn't just failing, it is being chemically leaked away into the void. To the observer on the ground, the horror is masked by a deceptive beauty. The blue night has arrived. People step out of their darkened homes, drawn by the strange, shadow-casting light of the new star, and they look up into a sky that is no longer black. It is a bruised, glowing violet, shimmering with an intensity that makes the stars around it vanish. They see the beauty of the too late moment, unaware that the very light they are admiring is the byproduct of a process that is stripping away their protection from the sun. They are witnessing the interpretation challenge on a global, psychological scale, the human brain's inability to reconcile a celestial wonder with a planetary death sentence. While the public watches in awe, the global scientific community is in a state of absolute, paralyzed realization. The data from the few surviving ground-based sensors confirms what the neutrino glitch and the electromagnetic cascade had hinted at. This isn't a localized event and it isn't terrestrial. It is the arrival of a supernova's wavefront from within the 50 light-year danger zone. The fact that we are seeing it and feeling its radiation simultaneously means we are in the worst-case scenario, the too late paradox, where the buffer of distance has finally hit zero. We are not spectators watching a distant explosion. We are the target of its cooling shockwave. The atmosphere's color change is just the visible surface of a deeper, invisible trauma. The X-rays, having spent their energy ionizing the upper air, begin to generate secondary particles that rain down toward the surface. This is the beginning of the muon rain, a secondary radiation dose that can penetrate deep into buildings and even underground bunkers. While people are mesmerized by the violet sky, their DNA is already beginning to receive hits from particles that can pass through the roof of a house as if it were made of paper. The psychological tension of this moment cannot be overstated. For the first time in history, the entire human race is looking at the same thing and feeling the same primal, existential dread. The sky, which has been a stable, predictable backdrop for all of human evolution, has become a dynamic and hostile presence. The illusion of cosmic silence has been shattered. We are realizing, in the most violent way possible, that we are not living in a protected sanctuary but on a fragile rock in a high-energy shooting gallery. As the hours pass, the eerie glow of the ionized atmosphere begins to interact with our planet's magnetic field in even more complex ways. The aurora displays, normally confined to the freezing loneliness of the poles, begin to march toward the equator. Brilliant, blood-red and emerald curtains of light begin to dance over the skyscrapers of New York, the deserts of the Sahara, and the rainforests of the Amazon. It is a global light show of unprecedented beauty, but it is a beauty born of violence. Each flare of the aurora is a sign that the Earth's magnetic shield is being pushed to its breaking point by the incoming particle storm. The day the sky changed color is the turning point of our species' story. It is the moment we move from a technological, confident civilization to a biological one, desperately trying to survive a change in our environment that we cannot control, and did not see coming until it was already here. The violet sky is a reminder that the universe is not obligated to be safe or understandable. It is merely moving at the speed of light, and today that light has finally reached us. As the sun begins to rise on the day after the arrival, the horror takes on a new, more physical dimension. The violet glow of the night doesn't simply disappear into a normal day. Instead, it is replaced by a thick, brown haze, the physical accumulation of the nitrogen oxides created by the radiation. The sun, which should be a welcome sight, looks different through this chemical veil. It is dimmer, yet more angry, its ultraviolet light now pouring through the thinning ozone layer with a ferocity we have never experienced. The spectacle is over. The too late moment has passed. Now the slow, agonizing process of ecological collapse is about to begin. The silent, digital blackout of the electromagnetic cascade was merely the breath before the scream. As the hours of confusion pass, the transition from an invisible sabotage to a visible cataclysm begins with a transformation of the sky that defies every human instinct for safety. The silent sky you once knew, that ancient velvet backdrop of predictable stars and comforting darkness, is officially dead. In its place comes a phenomenon known as the blue night, a steady, haunting radiance that signals the dismantling of our atmosphere's chemical foundations in real time. It begins as a faint, violet fringe on the horizon, but it quickly bleeds into the zenith until the entire dome of the world is saturated in a bruised, glowing bluish-white luminescence. This isn't the flickering, ethereal dance of a solar aurora. This is a heavy, pressurized glow, an eerie light that is bright enough to cast hard, ink-black shadows across the landscape, even at the stroke of midnight. This light is the visual signature of a planetary-scale laboratory, and we are the subjects trapped inside the flask. While the public steps out of their darkened homes, drawn by the strange beauty of a sky that refuses to turn black, they are witnessing the interpretation challenge on a global scale. The human brain, evolved to find wonder in the heavens, struggles to reconcile this celestial spectacle with the reality of a planetary death sentence. What looks like a miracle is actually the sound of our oxygen and nitrogen being ripped apart at the molecular level. The gamma rays and X-rays from the supernova's wavefront have finally arrived, and they are hitting our upper atmosphere with the concentrated energy of 1 trillion hydrogen bombs. Deep within the ionosphere and stratosphere, the violence is absolute. Nitrogen molecules, which are held together by some of the most powerful triple bonds in nature, are being severed by the incoming radiation. These liberated nitrogen atoms, now highly reactive and excited by the energy of a dying star, begin a desperate, chaotic hunt for new partners. They collide with oxygen molecules, creating an ionized plasma of gas that generates the steady, violet-white glow. But this chemical recombination is doing more than just lighting up the night. It is creating an assassin. The reaction produces massive quantities of nitrogen oxides, the very same toxic compounds that comprise industrial smog, but created here at altitudes that turn them into a weapon against life itself. This is the beginning of the ozone erasure, a process where our primary shield is systematically converted into a poison. Under normal conditions, the ozone layer is a thin, fragile sanctuary in the stratosphere that absorbs the sun's lethal ultraviolet radiation. But nitrogen oxides act as a catalyst for destruction. A single molecule of nitrogen oxide can eat through thousands of ozone molecules, chemically converting them into ordinary oxygen. In these first few hours of the blue night, our atmosphere is essentially leaking its protection away into the void. The shield is not just failing, it is being dismantled from the inside out by the very energy we are admiring in the sky. The implications of this silent sky being replaced by the blue night are as psychological as they are biological. The world no longer truly sleeps. The disruption of circadian rhythms begins immediately as the constant, piercing intensity of the supernova light rewrites the night. Wildlife is thrown into a state of total, frantic confusion. Nocturnal animals, adapted for millions of years to hunt in the shadows, find themselves exposed in a world where there is no longer a place to hide. Humans too feel the primal, existential dread of a sky that has become dynamic and hostile. The illusion of cosmic silence has been shattered, replaced by the realization that we are living on a fragile rock in a high-energy shooting gallery. As the ozone is stripped away, the atmosphere begins to undergo a more physical transformation. The violet glow of the ionized gas is the first phase, but it soon leads to a more insidious buildup. The nitrogen oxides don't stay in the upper atmosphere forever. They begin to accumulate, eventually forming a thick, brown haze that will replace the eerie blue light of the first night. This haze is the physical manifestation of the catastrophe, a chemical shroud that will dim the sun while simultaneously allowing its most dangerous ultraviolet rays to pour through the thinning ozone. By the time the first blue night begins to fade into the dawn of the next day, the planet's respiratory and protective systems have already been compromised. The tragedy of the blue night is its deceptive beauty. Most people will spend these critical hours staring upward, captivated by the emerald and blood-red auroras that have begun to march from the poles toward the equator as the magnetic shield is pushed to its breaking point. They will take photos of the shadow-casting guest star and the violet luminescence of the clouds, unaware that every second they spend under that glowing sky, their DNA is being hit by secondary radiation particles known as the muon rain. These particles, created by X-rays ionizing the air, can penetrate deep into buildings and even underground bunkers, passing through roofs and walls as if they were made of paper. While we were blind to the silence of the vacuum, we are now blinded by the brilliance of the disaster. We have moved from a technological civilization to a purely biological one, desperately trying to survive an environmental shift that we saw coming too late to mitigate. The blue night is the final transition point. It is the moment the too late paradox moves from the theoretical debates of subterranean labs into the lived experience of every human being on Earth. Our primary shield is becoming a toxic laboratory, and the sun, our ancient source of life, is about to become our greatest threat. The atmosphere we are breathing is the same one that is currently being chemically rewritten by a star 50 light-years away. The nitrogen we once thought was inert is now a catalyst for our destruction. As the midnight shadows lengthen under that piercing cold light, the reality of the ozone erasure begins to set in. We have lost our protection, and the silent, invisible deluge of ultraviolet light is preparing to strike the foundation of our world. The spectacle is over, and the slow, agonizing process of ecological collapse is now inevitable. We are no longer watching the universe. The universe, in all its violent creative power, has finally reached out to touch us. Within weeks of the first violet flash, the spectacle of the blue night begins to curdle into a cold, physical reality as the eerie, shadow-casting light of the supernova fades and reveals a sky that is fundamentally broken. The chemical leaking of our ozone layer, catalyzed by the massive influx of nitrogen oxides created during the initial radiation blast, has reached a tipping point. What was once a vibrant protective shield is now a transparent window for a lethal ultraviolet deluge. This is the moment the too late paradox moves from the atmosphere to the biosphere, targeting the very foundation of life on Earth, the phytoplankton. While previous documentaries focused on the immediate scorching of the surface, they ignored the unanswered mystery of the food chain, the terrifying reality that our planet is entering a respiratory crisis because the organisms responsible for every second breath we take are being systematically erased. Phytoplankton are the silent engineers of our world, microscopic powerhouses drifting in the upper layers of the ocean that produce up to 50% of the oxygen in our atmosphere. They rely on the sun for life, but they have evolved under the specific protection of the ozone layer. As the ultraviolet levels at the surface climb beyond typical ranges, these organisms find themselves exposed to a ferocity of radiation they have no biological defense against. The high-energy UV rays don't just burn them, they penetrate their microscopic bodies and shatter their cellular machinery. Photosynthesis, the process that fuels the entire marine world and replenishes our air, begins to fail on a global scale. This is the beginning of the Foundation collapse, a planetary-scale disaster that starts with a quiet, invisible mass death in the sea. As phytoplankton populations begin to crash, the ripple effects move upward through the marine food web with devastating speed. Small marine organisms that feed on these microscopic plants begin to starve, followed by the fish populations that depend on them. Fisheries, an essential food source for billions of humans, face an immediate and total destabilization. But the unanswered mystery is deeper than just a shortage of food. It is a question of atmospheric survival. The human brain struggles to comprehend a threat to the air itself. We have always assumed that the oxygen we breathe is a constant, a geological given. But as the phytoplankton die-off accelerates, we are confronted with the terrifying realization that we are living on a finite reservoir. The decline in oxygen production isn't immediately visible. You won't walk outside and gasp for air the next day. But the trend lines in scientific observatories begin to point toward a slow planetary suffocation. The too late paradox has effectively cut off the lungs of the Earth, and because we missed the initial neutrino warning, we are only now realizing that the Foundation collapse has been underway since the first night of the violet sky. On land, the story is equally grim as the ultraviolet deluge turns the sun into a hostile presence. Forests begin to brown and die as the most sensitive plant species find their leaves damaged and their growth stunted. Agricultural crops, many of which are highly vulnerable to UV radiation, face unprecedented challenges. Farmers around the world watch as their yields decline, leading to economic and social upheaval on a global scale. The very architecture of our food systems was built on the assumption of a stable ozone layer, and without it, the base of the terrestrial food chain begins to buckle. The most insidious part of this collapse is the effect on DNA itself. Ultraviolet radiation is a powerful mutagen, and as levels increase, mutation rates in every living organism on the surface begin to soar. While most of these mutations are harmful or fatal, they signify a fundamental shift in the biological landscape of Earth. Life is being forced to adapt or fail in real time, driven by an environmental pressure that humanity saw coming too late to mitigate. Skin cancer rates skyrocket, and eye damage becomes a global health crisis as even brief exposure to the sun becomes dangerous. This is the interpretation challenge at its most visceral. We are no longer debating sensor glitches in a lab. We are watching the base of our civilization's survival, food and air, dismantle itself. The social and cultural effects are transformative and terrifying. As food becomes scarce and health advisories become a permanent way of life, the collective consciousness of humanity shifts. We are realizing that the illusion of cosmic silence was the only thing that allowed us to believe we were in control. The universe is not a static backdrop. It is a dynamic, high-energy environment that has finally reminded us of our place within it. As the weeks turn into months, the silent sabotage of the phytoplankton crisis becomes impossible to ignore. The oceans, which cover 70% of our planet, are changing in ways we have never recorded. Marine biologists, working in the few functional research facilities left, observe a total reorganization of life in the sea. Some organisms prove resilient, but many face rapid extinction, leaving empty niches in a food web that has existed for millions of years. The spectacle of the supernova has long since faded from the headlines, replaced by the grim daily reality of an ecological reckoning. We are a species that has moved from a technological civilization to a purely biological one, struggling to adapt to a world where the very sky is a catalyst for destruction. The too late paradox has stripped away our protection and our arrogance, leaving us to wonder how we could have been so blind to the silence of the stars. We were looking for a sign in the heavens, but we ignored the signal that told us the foundation was already failing. The ultraviolet deluge is the physical manifestation of our cosmic vulnerability, a reminder that distance was never safety, it was only a delay. As we navigate this new, harsh reality, the unanswered mystery of the food chain remains our greatest challenge. Can we develop the technology to protect our crops and our oceans before the collapse becomes total? Can we find a way to stabilize an atmosphere that is being chemically rewritten by a star 50 light-years away? The answers will determine the long-term fate of Earth, But for now, we are a planet in a state of respiratory crisis, breathing in the legacy of a stellar death we saw coming too late. The day the sky changed color was the turning point, but the phytoplankton crisis is the true test of our resilience. We are no longer spectators in a cosmic drama. We are participants in a struggle for survival that touches every level of life on our small blue rock. And as the sun rises each day, its light serves as a constant piercing reminder of the too late paradox. The realization that the universe doesn't wait for us to be ready. It simply moves at the speed of light, and today that light is tearing at the very foundations of our world. The spectacle is over, the silent sabotage is complete, and the slow, agonizing process of ecological collapse is now our only history. But even as the foundation buckles, a new, more terrifying radiation is preparing to descend, a secondary wave that can penetrate the very earth we stand on, the moon rain. As the world watches the foundations of the ocean collapse and the sky dissolve into a thick, toxic haze, a new and even more insidious threat begins to descend, one that cannot be seen, felt, or blocked. While we have spent weeks obsessing over the visible blue night and the ultraviolet deluge, we have ignored the silent secondary wave of the supernova that is currently passing through our very bodies. This is the beginning of the muon rain, a phenomenon where the energy of a dying star is converted by our own atmosphere into a relentless, high-energy particle bombardment. For years after the initial flash, Earth will be subjected to a muon flux that is 150 times higher than anything in recorded human history. And in this new high-radiation reality, the laws of biology are being brutally rewritten. The larger you are, the faster you die. This is the megafauna killer, a cosmic filter that targets the giants of our world and leaves us with the terrifying realization that there is no hiding from a star that has decided to kill us. To understand the muon rain, we have to look at the silent sabotage happening in our upper atmosphere. When the primary wave of X-rays and gamma rays from the supernova slams into our air, they don't just create the eerie violet glow of the ionized sky, they trigger a cascade of nuclear reactions. These high-energy photons strike atmospheric nuclei, creating a shower of secondary particles that rain down toward the surface. Among these particles are muons, the heavy, unstable cousins of the electron. A muon is essentially an electron with a midlife crisis. It is more than 200 times heavier and carries a tremendous amount of kinetic energy, allowing it to move at nearly the speed of light. But unlike the UV radiation that is currently scorching the surface, muons do not care about shielding. This is the most disturbing implication of the too late paradox. Most people assume that if a cosmic disaster struck, they could find safety in lead-lined bunkers, deep basements, or thick-walled buildings. But the sources reveal that muons can penetrate deep into the earth, passing through roofs, walls, and miles of solid rock as if they were made of paper. The very ground we stand on, which we once viewed as a sanctuary, has become a radiation chamber. While we were distracted by the visible collapse of the food chain, the muon rain began a slow, agonizing assault on the DNA of every living creature on the planet, reaching down into the bone marrow where no other radiation can go. The muon flux theory introduces an unanswered mystery that has haunted paleontologists for decades. Why do some extinction events seem to specifically target the largest animals? The physics of the supernova provides a chilling answer. Because muons are so penetrating, the radiation dose an organism receives is not determined by its skin or its surface area, but by its total volume. This creates a lethal size tax on life. A small rodent or a microscopic organism might be struck by a handful of muons a day, but a large animal, an elephant, a giraffe, or a human, presents a much larger target. Their bodies absorb a disproportionately higher lethal radiation dose simply because they occupy more space in the path of the rain. This isn't just a theoretical model, the sources provide the smoking gun in our own geological history. Approximately 2.6 million years ago, our early human ancestors, like Australopithecus, looked up to see a supernova that had exploded roughly 150 light-years away. We know this because scientists found traces of iron-60 in sedimentary rocks at the bottom of the Pacific Ocean, an isotope that can only be forged in the heart of a supernova and has a half-life that perfectly matches this ancient event. This period coincides with the Pliocene-Pleistocene boundary, a time of dramatic change in the fossil record where nearly one-third of the world's marine megafauna suddenly vanished. The tragedy of the Pliocene megafauna is a direct preview of our too late scenario. During that ancient event, large marine mammals were decimated, but the extinction pattern was strange. Animals living in shallow waters were far more likely to go extinct than those living at great depths. The sources explain that while muons can penetrate hundreds of meters of water, the sheer volume of the deep ocean eventually provides enough shielding to protect the life below. But for the giants of the shallows, the great whales and the massive sharks of the era, there was no escape. They were caught in the muon trap, receiving 150 times their normal radiation dose for years on end, leading to reproductive failure, massive cancer rates, and the eventual collapse of their species. This brings us to the psychological horror of the muon rain for a modern technological civilization. We are a species that prides itself on our ability to build our way out of any problem. We have developed space-age materials and deep Earth storage, but the muon rain renders our most advanced architecture irrelevant. As the years of the post-supernova era grind on, we are forced to confront the interpretation challenge at its most personal level. We aren't just watching the climate shift or the phytoplankton die. We are feeling our own biological clocks being accelerated by a stellar ghost. The muon rain is the ultimate invisible saboteur. In the weeks following the Foundation collapse, society is already reeling from food shortages and atmospheric poisoning. But the muon rain is a long-term environmental pressure that ensures the crisis does not end. It is a constant, unrelenting background radiation that increases mutation rates and raises the tax on complex life. For humans, this means a global health crisis that no hospital can treat and no vaccine can prevent. We are living through a planetary lobotomy, where the very air we breathe is generating the particles that are slowly dismantling our genetic code. The too late paradox has effectively turned the surface of the Earth into a hostile environment for large-bodied life. We are seeing the illusion of cosmic silence replaced by a world where the only survivors are those small enough to hide or those lucky enough to live in the deep, lightless voids of the planet. The giants of our era, the whales in our oceans and the remaining megafauna on our plains, are the first to falter. They are the canaries in the coal mine for a world that has been struck by a supernova, proving that in the eyes of the cosmos, being a successful species is a temporary luxury that can be revoked at any moment by a star 50 light-years away. As we stand in our homes feeling the phantom itch of a radiation we cannot see, we have to ask the unanswered mystery of our own future. If the muon rain persists for decades, what becomes of the human form? Are we destined to follow the path of the Pliocene giants, becoming a memory in a layer of iron-60 for some future civilization to find? The sources suggest that while Earth will survive and life will persist in some form, the era of the giants is over. We are now participants in a high-stakes evolutionary gamble, driven by a muon flux that is demanding a rapid, radical adaptation that our biology might not be able to provide. The muon rain is the final crushing weight of the too late paradox. It is the reminder that the universe does not just kill with fire and light. It kills with the steady, patient accumulation of heavy particles that bypass every defense we have. We were waiting for a spectacle, a day the sky changed color, but the real reckoning is happening in the silence of our cells, in the deep penetrating rain that started before we even knew the star was dead. The sky has stopped glowing, but the stars are still reaching out to touch us, one muon at a time, ensuring that the legacy of the supernova is written in the very marrow of the survivors. And as the 50 light-year ghost finally begins to reveal its true identity in our telescopes, We are left to wonder if identifying the killer even matters when the weapon is already inside us. While our bodies absorb the silent weight of the mooing rain and our oceans begin their slow, respiratory collapse, a frantic, desperate investigation is unfolding in the world's remaining observatories. The question is no longer what is happening. The bruised violet sky and the digital blackout have answered that with terrifying clarity. The question that haunts the survivors, from the bunker-bound remnants of space agencies to the amateur astronomers tracking the guest star with manual lenses, is simpler and more haunting. Who is the killer? For decades, we believed we had mapped every threat in our celestial neighborhood. We catalogued the giants, measured the distances, and congratulated ourselves on the safe distance of our nearest neighbors. But as we scramble to identify the progenitor of this cataclysm, we are forced to confront the 50-light-year ghost, the terrifying reality that our maps were a lie and we are currently being haunted by a star we never even knew was a threat. The investigation begins with the usual suspects. For years, whenever the subject of a nearby supernova arose, one name sat at the top of every danger list: IK Pegasi b. Located approximately 150 light-years away, this binary system was the nearest known supernova progenitor candidate. It isn't a massive supergiant like Betelgeuse, it is something far more surgical, a massive white dwarf orbiting an ordinary star. In our old safe distance models, 150 light-years was considered a comfortable buffer, a distance where an explosion would be a spectacular light show rather than a planetary execution. But the too late paradox has shredded those models. As scientists analyze the intensity of the radiation hitting the ionosphere and the density of the iron-60 isotopes beginning to settle in our upper atmosphere, they realize the energy output doesn't match a source 150 light-years away. If IK Pegasi b had detonated, the impact should have been a whisper. What we are feeling is a roar. This leads us to the most disturbing possibility from the law vault: the dark supernova. We have spent centuries operating under the assumption that we would see a supernova coming because space is a transparent vacuum. But space is not empty. It is filled with vast, undulating shrouds of interstellar dust. These clouds act as a cosmic mask. If a star detonated behind one of these veils, the visible light, the very signal we rely on to see the event, would be scattered and absorbed, rendered invisible to the naked eye until it was far too late. However, the high-energy X-rays and gamma rays, the invisible hammers currently stripping our ozone, can penetrate this dust with lethal efficiency. We are realizing that our danger zone was populated by ghosts, stars that were perfectly positioned to kill us, but remained hidden behind a curtain of cosmic soot. As we try to reconstruct the identity of the killer through chemical and kinetic analysis of the radiation, a deeper, more existential horror begins to emerge. We aren't just looking at one dead star, we are looking at the history of our own neighborhood. Astronomers have long known that our solar system exists inside a cosmic void, a low-density bubble of space where there are 1,000 times fewer hydrogen atoms than the galactic average. For years we viewed this local bubble as a sanctuary, a quiet clearing in the crowded woods of the Milky Way. But as we process the data from the current explosion, the interpretation challenge shifts from science to survival. We realize that this void isn't a sanctuary, it's a graveyard. This bubble was likely carved out by tens of supernovae that exploded in our immediate vicinity millions of years ago, blowing the interstellar medium outward like a cosmic leaf blower. We are the survivors of a historical bombardment we simply forgot to remember. We looked at the empty space around us and assumed the current quiet was the norm, rather than a temporary lull in a long-term cycle of violence. The 50 light-year ghost is a reminder that we are living in a shooting gallery where the previous shots have already cleared the air. The illusion of cosmic silence was the only thing that allowed us to believe we were safe. We assumed that because no massive supergiant was currently visible within 50 light-years, we were protected. But the too late paradox suggests that the most dangerous stars are the ones you can't see, the white dwarfs in binary systems, like the merger that created Kepler's supernova in 1604, or the dark stars masked by dust that give no warning until their radiation wavefront arrives at the speed of light. The psychological impact of this realization is staggering. Humanity has spent its entire history looking up at the constellations as symbols of permanence and guidance. We named them, told stories about them, and navigated our ships by them. But we are now discovering that the sky is a minefield of delayed messages. The star that is currently killing us may have died decades ago, its light and its weapon traveling together in a silent 186,000 mile per second package that we only opened when the first satellites began to fail. We are realizing that distance was never a buffer, it was only a delay. In the final, desperate attempts to triangulate the source, scientists look for traces of manganese-53 and iron-60, the radioactive isotopes that serve as the fingerprints of a supernova. These are the same elements found in the sedimentary rocks of the Pacific, proving that 2.6 million years ago, our ancestors, the Australopithecus, witnessed a similar 50 light-year ghost. That event wiped out a third of the marine megafauna, a preview of the megafauna killer currently acting on our own world. We are part of a recurring cosmic drama, a cycle of death and rebirth that we are only now beginning to understand because we are currently its primary target. The realization of the cosmic void changes everything about our place in the universe. We are not an isolated oasis. We are an accidental survivor of a local history of violence. Every element in our bodies, from the iron in our blood to the gold in our technology, was forged in the very explosions that now threaten to erase us. There is a haunting circular poetry to it. We were born from the stardust of ancient supernovae, and we are now being unmade by the arrival of the next one. The 50 light-year ghost isn't just an external threat. It is our ancestor, our creator, and now our executioner. As the telescopes continue to scan the bruised violet sky, searching for the fading embers of the progenitor, the identity of the star starts to matter less than the reality it has revealed. Whether it was I-K Pegasi b finally reaching the Chandrasekhar limit, or a dark supernova emerging from a cloud of dust, the outcome is the same. The too late paradox has proven that for a technological civilization, the first moment of awareness is also the moment of peak vulnerability. We have lived our entire history in a room with a 50-year delay on the windows, and by the time we saw the fire, the glass was already melting. We are left with the chilling understanding that the universe doesn't owe us a warning. It simply moves at its own speed, carrying its billion-year-old messages of destruction across the void. The 50 light-year ghost is the final shattering of our cosmic arrogance, the proof that we were never the masters of the heavens. We were merely guests in a graveyard, enjoying a few million years of quiet before the next inhabitant decided to wake up. And as the radiation continues to pour in, turning our atmosphere into a toxic laboratory and our cells into a battleground for muons, we are forced to admit the ultimate unanswered mystery. We spent so long looking for a sign in the heavens, but we were looking for a light in the dark, failing to realize that the real threat was the darkness that arrived before the light. The ghost has finally revealed itself, but identifying the killer doesn't change the fact that the weapon is already inside us. As the eerie, shadow-casting light of the 50 light-year ghost begins to wane, leaving behind a sky choked with a thick, brown chemical haze, a profound shift in the narrative of our survival begins to take hold. Up until this point, we have viewed the nearby supernova as a purely destructive force, a celestial executioner that stripped our satellites, poisoned our air, and collapsed the foundation of our food chain. We have mourned the megafauna killer and the silent, penetrating moon rain that bypassed every bunker we built. But as the years of this new reality grind on, a more complex and disturbing truth emerges from the wreckage of the biosphere. The radiation from the dying star is not just a killer, it is a mutagen. We are entering the era of the evolutionary accelerator, a phase where the too late paradox forces a radical, high-speed rewriting of the genetic code of every living thing on Earth. In this chapter of our history, the survivors will not simply be the ones who managed to hide, they will be the ones whose biology was fundamentally transformed by the very event that tried to erase them. To understand this transformation, we must look at the nature of the bombardment we are currently enduring. The ultraviolet deluge, no longer held back by our erased ozone layer, is striking the surface with a ferocity that shatters molecular bonds. Simultaneously, the muon rain continues to saturate the planet, delivering a secondary radiation dose that reaches deep into the bone marrow and the reproductive organs of every survivor. In the world of safe distance models, radiation is a poison to be avoided, but in the reality of a nearby supernova, radiation is an information storm. Every gamma ray, X-ray, and muon that strikes a cell is a potential bit flip in the binary code of life, a random edit to the DNA sequence that has remained stable for millions of years. This is the interpretation challenge applied to biology. Most of these genetic edits are catastrophic, leading to reproductive failure, cancer, and the planetary lobotomy of complex ecosystems. However, on a global scale involving trillions of organisms, a tiny fraction of these mutations are not errors, but innovations. The evolutionary accelerator theory suggests that nearby supernovae are the universe's way of stirring the pot, forcing life into a state of high-speed experimentation. Normally, evolution moves at a glacial pace, a slow accumulation of changes over eons. But under the intense pressure of a 150 times higher radiation flux, the rate of genetic change is pushed into overdrive. Life is being forced to adapt or fail in real time, and the survivors of the too late explosion will be biologically distinct from those who witnessed its start. We have seen this evolutionary accelerator in action before, and it may be the very reason our ancestors survived to tell the tale. The smoking gun found in the iron 60 layers of the Pacific Ocean tells a story of a supernova that detonated 2.6 million years ago. That event, which triggered the extinction of the Pliocene megafauna, also coincided with a dramatic shift in the fossil record. The theory suggests that the environmental stress and the mutagenic rain from that ancient explosion may have been the catalyst that pushed our ancestors, like Australopithecus, to undergo rapid changes. We are, in a very real sense, the children of a supernova, a species forged in the radiation of a dying star that arrived too late for our ancestors to understand, but just in time to change them. Now, as the current cataclysm unfolds, we are seeing the same process repeat on a global scale. The unanswered mystery of our future lies in who will emerge from this filter. The giants, the megafauna, are being systematically erased by the volume-based size tax of the muon rain. But in the shadows and the deep places, life is already beginning to rewire itself. We are witnessing the rapid evolution of enhanced DNA repair mechanisms, cellular systems that can identify and fix radiation damage faster than it can accumulate. Plants are developing thicker, waxy coatings and novel pigments that can absorb and neutralize the ultraviolet deluge. The biosphere is not just dying, it is hardening. For humanity, the shift is even more profound because it is both biological and psychological. As the illusion of cosmic silence is replaced by the reality of a high-energy sky, a new form of cosmic consciousness begins to emerge. Children born into the aftermath of the too-late explosion do not see the sky as a stable, eternal backdrop. They see it as a dynamic, dangerous, and creative force. They grow up with an intuitive understanding of the connections between the stars and their own survival. Their nervous systems, developed under the constant, low-level stimulation of the muon rain and the perpetual glow of the auroras, may even process information in ways that neuroscientists are only beginning to understand. They are the first generation of a new human trajectory, one that has been accelerated by the death of a star 50 light-years away. This is the great irony of the too-late paradox. We spent centuries looking for a sign in the heavens that would give us time to prepare, to hide, and to stay exactly as we were. We wanted to protect the world we knew. But the universe doesn't offer protection, it offers transformation. By arriving too late for us to deploy our technological shields, The supernova forced us to engage with its energy on a biological level. It bypassed our computers and struck our cells. It didn't just change our world, it is changing us. The survivors will carry the legacy of this star in their very marrow, their DNA, a permanent record of the delayed message that finally reached home. The tone of the disaster has shifted from one of mourning to one of eerie, high-stakes anticipation. We are no longer merely victims of a cosmic accident, we are participants in an evolutionary gamble. The 50-light-year ghost has finished its initial assault, and now it is acting as a sculptor, carving away the old forms of life and leaving behind the blueprints for the new. We are witnessing the birth of species that can thrive in high UV environments, organisms that can utilize the exotic isotopes delivered by the explosion, and a humanity that no longer feels separate from the stars. The interpretation challenge is no longer about identifying the star, it is about identifying our place in the new world it has created. We are discovering that the cosmic void we inhabit was not an empty sanctuary, but a cradle of violence that has shaped life on Earth for billions of years. The current supernova is just the latest beat in a galactic heart that has been pumping radiation and innovation into our biosphere since the beginning. We were looking for a light in the dark, but we found a fire that is tempering us for a future we couldn't have imagined. As we stand on the threshold of this new era, we must confront the final disturbing implication of the evolutionary accelerator. The survivors of this event will be fundamentally different from those who witnessed its start. They will possess a resilience, a biology, and a perspective that makes them strangers to their own history. They will look back at the people of the silent sky era as a primitive, fragile version of themselves, a species that lived in a room with a 50-year delay on the windows and never realized the fire was already inside. The too late paradox has served its purpose. It has stripped away our technological arrogance and returned us to the raw biological struggle that defines life in a high-energy universe. We are no longer spectators, we are the stardust legacy in the making. And as we prepare for the final chapter of this cosmic drama, we realize that the same event that threatened to end our story is the only reason our story can continue to evolve. The star is dead, the weapon has landed, and the accelerator is running at full speed. All that remains is to see what we will become when the light finally fades. As the long, bruised violet of the blue night finally begins to recede, and the thick, brown haze of the chemical sabotage starts to settle, we are left standing in a world that is fundamentally unrecognizable. We have endured the collapse of our electrical grids, the blinding of our satellites, the poisoning of our atmosphere, and the silent, deep, penetrating muon rain that has rewritten our very marrow. We have seen the foundation of our oceans buckle as the phytoplankton perished, and we have watched the giants of our era fall to a cosmic filter that targets the large and the complex. The too late paradox has stripped us of our technological arrogance and returned us to the raw, biological struggle that defines life in a high-energy universe. But as we survey the wreckage of the world we once knew, we are confronted with the final, most profound interpretation challenge of the entire catastrophe. We are realizing that the very event that threatened to end our story is the only reason our story was ever possible to begin with. There is a haunting circular poetry to our survival. For all the terror of the 50-light-year ghost, this celestial executioner is also our most ancient ancestor. As we struggle to rebuild a society under the constant shimmering glow of perpetual auroras, we must look inward at the very chemistry of our own bodies. The iron that carries oxygen through your veins, allowing you to breathe in this newly hostile atmosphere, was not forged in a peaceful sky. It was created in the exact same kind of violent supreme compression that we just witnessed, a stellar core collapsing in less than a second, reaching temperatures of 100 billion degrees. Every heartbeat you feel is powered by the legacy of an ancient supernova that died billions of years before our sun was even a spark in the dark. This is the Stardust Legacy, the closing of a loop that spans the entire history of the cosmos. We are not separate from the violence of the universe. We are a temporary arrangement of its debris. The gold in the microchips of the satellites that failed us, the uranium that powers our desperate search for energy, and the platinum in our most advanced medical tools were all forged in the final, agonizing seconds of a star's life. The universe does not just kill with fire and light. It uses that fire to cook the heavy elements that make complex chemistry and life itself possible. We were born from the ashes of ancient stellar fires, and we are now being tempered by the arrival of the next one. As we navigate the evolutionary accelerator, we are forced to acknowledge a truth that modern astronomy spent centuries trying to glaze over. We are accidental survivors of a local history of extreme violence. Our solar system exists inside a cosmic void, a graveyard carved out by tens of supernovae that exploded in our immediate vicinity millions of years ago. We looked at the empty, quiet space around us and assumed we were in a sanctuary, failing to realize that the silence was merely the delay between shots in a cosmic shooting gallery. Approximately 4.6 billion years ago, it was likely the shockwave from a nearby supernova, just like the one we saw coming too late, that triggered the collapse of the vast cloud of gas and dust that eventually coalesced into the Earth and everything on it. The trigger for our destruction is the same trigger that started our creation. This realization shifts the tone from one of mourning to one of eerie, high-stakes anticipation. We are no longer merely victims of a cosmic accident. We are participants in a cycle of death and rebirth that has been stirring the pot of galactic evolution since the first stars ignited. The too late paradox was never just about a failed early warning system. It was a reminder that for a technological civilization, the first moment of awareness is the moment we are invited back into the cosmic dance. By arriving too late for us to hide behind our digital shields, the supernova forced us to engage with its energy on a biological level, striking our cells and accelerating our evolution. The survivors of this era, the children of the supernova, will look up at the sky with a perspective we can barely imagine. They will grow up in a world where the illusion of cosmic silence has been shattered forever. To them, the stars are not distant, eternal constants, but dynamic and dangerous parents. They will understand intuitively that the iron in their blood and the gold in their tech are delayed messages from the past, reminding them that they are made of the very stuff that can erase them. They will possess a cosmic consciousness, a deep awareness of the interconnectedness between their terrestrial survival and the high-energy events occurring light years away. We have spent our history in a room with a 50-year delay on the windows, watching a beautiful garden and never realizing the glass was starting to melt. But as the light of the 50 light-year ghost finally begins to fade into the background radiation of the galaxy, the glass has been removed. We are standing in the fire, and we are discovering that we are not being consumed, but refined. The interpretation challenge is complete. We no longer need to identify the killer because we have identified the source of our own resilience. The universe did not owe us a warning, and it did not promise us safety. It simply moved at its own speed, carrying its billion-year-old message of destruction and creation across the void. We saw it coming too late to stay the same, but we saw it in time to change. The silent sabotage of our technology was merely the prologue to the transformation of our biology. We are the stardust legacy in the making, the latest beat in a galactic heart that has been pumping innovation into the biosphere since the beginning. As you look up tonight beyond the thick haze and the dancing curtains of the aurora, remember that the silence is not a sign of peace, it is a sign of distance. Somewhere out there, another star has already died, and its weapon is already on its way, but do not look with fear. Look with the eyes of a species that knows it was forged in that same fire. We are the universe's way of understanding its own violent birth. We are the patterns of stardust that have learned to contemplate their own origin and destiny, survivors of a too late paradox that has finally, at long last, closed the loop. The light is fading, the accelerator is running, and for the first time in human history, we are finally truly awake to the cosmic dance.